Okay, dear Calculus 2 students, this is for you guys. We'll be doing some reviews on derivatives and also integrals. Because the first thing that we'll be starting with Calculus 2 is integration techniques. So you must remember the basic u-substitution and also the derivatives. And you guys can go download the file in the description for the problems. We have a total of 20 questions, and each question actually has two parts. So just like this, they will look really similar, but the approach to them, will be very different. And then I think that's the best way for you to be good at derivatives and also integrals. Because sometimes once you just change a little notation, the whole thing gets changed. You have to know when to do what really well. The first 5 questions would be just focusing on derivatives, and then from question 6 to question 10 will be integrals, and then the last 10 questions is both integration and derivative in the same question. Use the timestamps in the description though, so that way you can jump to which question that you need help with. Alright? And you need to remember the derivative table. Like the derivative of square root of x is 1 over 2 square root of x, and the derivative of cosecant is equal to negative cosecant x, cotangent x, etc, etc. You guys can go follow me on Instagram, because I actually have some notes that I'm making to like a picture slides. So you guys can go, follow and all that stuff. Anyway, let's get started. For the first one, you see that this and that look similar. By the way, this is part A, this is part B. Well, when we have the 3 right here, this means we have to differentiate. This is sine x inside and then raised to the 3rd power on the outside. Meaning we will have sine x times sine x times sine x. But this right here means we have sine, and then the input is x times x times x. So very different. For this, of course, we can first use the power rule, bring the 3 to the front, and then minus 1, everyone's favorite, right? So we get 3, and then we get the inside stays the same. So write down sine x, and then square, but we are not done yet because you have to remember to use the chain rule. Multiply by the derivative sine x, which is just cosine x, and that's pretty much it. But in the end, I would like to just write this 2 right here, so we have 3 sine square x cosine x, like so, and then we are done. If you leave the answer like this, that's totally okay. For the second one though, we first differentiate the sine function, which is going to be cosine, so let's go ahead and write that down, and then the input stays the same. But again, we have to look at the inside. We have to multiply by the derivative of x to the 3rd power, which is 3x squared. So let's just put that in the front, and that's it. 3x squared times cosine x to the 3rd power, that will be for the second one right here, right? Okay, so it wasn't too bad, right? And then we just have 19 more questions to go. It's not so bad. Let's see how long this takes. How's your summer? You haven't done calculus for the whole summer, maybe? When was the last time you guys did calculus? Okay, number 2. Second question, we are going to differentiate inverse tangent x. And then the second part is that we are going to differentiate x times inverse tangent x minus 1 over 2 ln 1 plus x squared. So this is the square. Alright, so let's take a look at the first part right here. It's actually not so bad. You just have to remember the derivative of inverse tangent x is just going to be 1 over 1 plus x squared, and you are done. I do want to make a quick note though. Whenever we have this -1 notation when we are talking about functions, this means the arctangent, which is just the inverse tangent function, right? So this is the inverse tangent function. So when we see the -1 right here, keep in mind, do not write it down like this. Do not say this is 1 over tangent x. Unfortunately, this is just perhaps a bad notation. Not a lot of people like this, but we just have to deal with it. This means the arctangent, which is another notation, which they all mean the inverse tangent function, and the derivative of that is 1 over 1 plus x squared. Good. Now for this part, it's longer, so be really careful. First, we have x times inverse tangent x. We have to use the product rule, so let's go ahead and do that. So let me put down a dot to remind us. The product rule is we are going to keep the first function and then multiply by the derivative of the second. The derivative of this is 1 over 1 plus x squared. And then we add the second function, which is just write that down, the inverse tangent. And then we multiply by the derivative of the first, which is just 1. Okay, and then we are going to do the next part, which is minus 1/2. And then for the ln of this, the derivative of ln is going to be 1 over whatever this is. So let's go ahead and put that down on the bottom, 1 plus x squared. But again, don't forget the chain rule. We have to multiply by the derivative inside. The derivative of 1 is 0, the derivative of x squared is 2x, so I can put that down on the top like that. Okay, now we see this and that cancel, and in fact, this is just x over 1 plus x squared, which is the same as x over 1 plus x squared, but that's positive, this is negative. So we are going to cancel this out. So that's pretty nice. Because you see that we actually end up inverse tangent x. Yeah, so have a look. The derivative of inverse tangent is equal to that. And the derivative of this will actually give you inverse tangent. The reason I did this right here is because later on we will see when we integrate inverse tangent x, we will actually get this right here. Yeah, but that's later on. That's when we are doing the integration by parts. But that's the second question. Right? So I picked these questions because I think they also have a pretty good purpose, mainly for review. So I want you guys to kind of get back into shape in terms of doing calculus. I don't know if you guys can tell or not, but like it's really hot right here, and I don't want to turn on the AC because it will be really loud. So yeah, so it's yeah, I'm just complaining. But anyway, number 3. Okay, it's a fun one too. So let's have a look right here. Number 3. First part, we will be differentiating e to the 1 over x power. And for the second part, let me just put that down right here. Versus, we will be differentiating, look the same, but it looks like this, 1 over e to the x. Alright, usually I like to ask the students which one is easier. Let's just do this one right here, right? So, but if you take a look at both, they should be equally easy. So let's just do this one first. Remember the derivative e to the whatever, you just repeat that first. So you are going to write this down, e to the 1 over x, just repeat that. But we will have to use the chain rule. So multiply by the derivative of this, which is going to be 1 over x squared, but negative. Ooh, why is that? Well, let me do that for you guys real quick. Derivative of 1 over x, we look at that as x to the negative 1 power. And we do the power rule, bring the negative 1 to the front and then minus 1. And we see that we just get negative and then x to the negative 2, which is negative 1 over x squared. However, you will see this kind of derivative a lot, so you should just remember it. You should be able to go from here to here every single time. That will save you a lot of time. But that's a little reason for that. Alright, so perhaps in the end we can just put this down nicely. So we will have negative e to the 1 over x squared, like so. Yeah. Okay, for the second one though, well, you see that we do have the entire e to the x on the bottom. So in this case, we can actually change the x to a negative x power. Have a look. This right here, it's the same as differentiating e raised to the negative x power. And the reason that you do this is because this way you do not have to do the quotient rule. So you see here, differentiating e to the whatever, you just first repeat that, but then we have to multiply by the derivative of the inner function, which is going to be negative 1. So have a look. We can put the negative 1 on the top. If you would like, you can just bring that down to the bottom. So perhaps we will, and make that into a positive x power right here. So negative 1 over e to the x power. Yeah, just like that, right? So hopefully this is going to be helpful, like a lot of little things that you guys did before, and oh, I haven't done that for a while, so okay, I start to remember it. That's the purpose of this video and then the first homework assignment for you guys. I'm not going to edit this video because editing will take too much time. I would rather use that time to produce more content for you guys. Alright, number 4. We will be first differentiating. The first version is 1 plus x to the 4th power over x squared. And for the second one, you want to take a guess? We'll actually just do the reciprocal. So here we are going to be differentiating x squared over 1 plus x to the 4th power. Okay, they both look like quotients, so should we use the quotient rules for both of them? Not necessary for the first one, because we have only x squared on the bottom, so this right here is the same as saying, again, I haven't done the derivative yet, we're just doing algebra first. We can look at this as 1 over x squared and then plus this over that. We can split the fraction, especially when we just have one thing on the bottom. And this is so beautiful because for the first one, again, we haven't done any derivative yet. I'm just rewriting the first one as x to the negative 2 power. And then for the second one, we can just do 4 minus 2 and we get x to the 2nd power. And now we can just simply do the power rule. So for this one, we can bring this power to the front, minus 1, and likewise do the same thing right here. And have a look. We'll just have negative 2, x to the negative 3, and then plus 2x to the 1st power. This is totally okay, but if you want to put that down to the bottom, that's fine as well. Doesn't matter, up to you. Alright, so that's number 4 for the first part. Well, if we do the reciprocal though, unfortunately, we really do have to use the quotient rule. So for the quotient rule, I will just work this out for you guys. Actually, let me remind you guys what the quotient rule is right here. When we differentiate, let's say we have two functions, f and g. Well, what we do first is look at the bottom function. We are going to square that. So I'm going to just write down g squared on the bottom right away. And the top is going to be the bottom function times the derivative of the top, f prime. And then minus, remember this right here is minus. Unlike the product rule you add. Quotient rule right here you have to subtract. Well, the second part right here is going to be the top function, which is f times the derivative of the bottom. So that will be the quotient rule. Alright, so let's go ahead and get that going. We will square the bottom, so we will have 1 plus x to the 4th power squared. Put the bottom to the top first, so we have 1 plus x to the 4. And we are going to multiply by the derivative of the top, which is going to be 2x. And then we are going to minus the top function, which is x squared, and we will multiply by the derivative of the bottom function. Derivative of 1 is 0, derivative of this is 4x to the 3rd power. And perhaps we can just multiply out the top and see if there's anything that we can cancel out. This times this, we get 2x, and then 2x to the 5th, and then we have minus 4x to the 5th. Remember to add the exponents, right? Over the bottom square, like that. We can combine this and that. So 2 and negative 4, we get negative 2. So this is 2x minus 2x to the 5th power over parentheses 1 plus x to the 4 square, and we are done. So that will be it. So not so bad, and of course the first one is easier, but you have to recognize we can do algebra first. For the second one, we just have to use the quotient rule, and you should remember the quotient rule. Yeah. In fact, you should remember all the integration techniques that you are going to see in the first 3 weeks. That will be way more important. I just want to check if I'm actually recording. I don't want the camera to somehow like all of a sudden just stop recording and then oh, I'm talking to nobody. That will be no good. Okay, number 5. Take a look right here for both of this. First one will be differentiating natural log function, and this right here we have x plus the square root of x squared plus 1. And for the second one, we'll be differentiating. We are going to take away that plus. So it's just ln of x and then square root and x squared plus 1. Yeah, so there's no plus sign here, but there is indeed a plus sign here. Okay, so now let's do the game. Which one is easier to differentiate? This one is slightly easier in my opinion, because remember what we did earlier? We were able to use algebra to simplify the expressions before we differentiate. We can do the same thing here, because this right here means we actually are multiplying here. So when we have natural log of this times that, we can rewrite this as, well, again, I haven't done the derivative yet. We can write this down as natural log of the first, which is ln x, and then we are going to add natural log of this. And I'm just going to put this down as the square root of x squared plus 1, like so. Well, now we can just differentiate them individually, but for this one, the reason I put the square root in red is because I'm going to look at the square root as the 1/2 power, as usual. So let's go ahead and do that. And what can we do with this? Because we have a natural log and this is a power, we can bring the power to the front. And do not minus 1. We are not doing the derivative yet. This is just the log property. So let me just write this down one more time. We haven't done the derivative yet. The first term is still natural log of x, but for the second one, we are looking at 1/2 ln x squared plus 1. Alright, now do the derivative. Derivative of natural log of x is 1 over whatever this is, just x, so that's it. And then we put down plus 1/2. Well, the derivative of this is going to be 1 over, and we can write that down first, here. And multiply by the derivative of the inside, which is going to be 2x. Okay, this and that cancel, so that's pretty much it. If you would like, you can just write it as 1 over x plus x over x squared plus 1. That is totally okay. If you want to combine the fractions, then you just do the following. I will use blue for that. Let's just go ahead and multiply x squared plus 1 here, and also x plus 1 here, x squared plus 1 here. And we will need to multiply by x here, right? So this way, we will be able to get the same denominator, namely x times x squared plus 1. I don't know if you guys can tell or not, but like, I actually do not like this blue marker. It's just... Let me get another one. Let me see. Hopefully this is better. Let's see. Anyway, this is x squared plus 1. X squared plus 1. Much better. Much more ink, right? And this is also x times x, so we have to add x squared, right? Well, of course, we can just add them up. So finally, I will just put down 2x squared plus 1 over x times x squared plus 1. Okay, this right here will be the answer. But again, we could have stopped it right here. 1 over x plus x over x squared plus 1, if you would like. But if it's a multiple choice question, then you just do maybe most likely that. Okay, anyway, for the second, for the first part right here, we cannot break down this at all, unfortunately. We just have to differentiate as how it is. Here we go. Differentiating ln of whatever, we can put that on the bottom first. So we are looking at, and this time, let me write it as 1 over that x, and then we have to add, and then we have, actually, let me do what I did earlier. So put this down on the bottom first. So we are looking at x plus square root of x squared plus 1. And now we are going to multiply by the derivative of the inside. The derivative of x is 1, and we have to add the derivative of the square root. Well, you have to remember that's going to be 1 over 2 square root of whatever that is. And again, let me just write that down real quick. When we differentiate square root of x, the first thing that we do is just write it as 1 over 2 square root of x. But we know this time though, we have the inside function. We have the inside function right here, which is the x squared plus 1. So that requires the chain rule, which is 2x. So I'm going to put that down on the top right here. Alright? So differentiating square root, you first put this on the bottom, but you have a 2. And then you multiply by whatever the derivative inside is. And the reason that this right here is because you look at the square root as the 1/2 power. You bring the 1/2 to the front and minus 1. That's how we get the 1/2. 1/2 minus 1 is negative 1/2. X to the negative 1/2 is the same as 1 over x squared. So that's how we get that. So these are the little things that you definitely have to remember. Okay, now the question is, well, yeah, I know this and that can be cancelled, so let's go ahead and do that. But can we do more? This is how we usually simplify expressions. We have a complex fraction because on the top we have a fraction inside of another fraction, right? So in this case, let's go ahead and do the following. We are going to multiply the top and bottom by the denominator here, which is going to be square root of x squared plus 1. So do the same thing here. Alright, let's have a look. This way, this times that, we get square root of x squared plus 1. And this times that, they cancel, so we have the x right here, and that's a plus x. So that's the numerator. And I will tell you, do not multiply out the denominator, because this right here goes here, right? X plus square root of x squared plus 1. And I'm just going to write that down right here again. Do we see it? Square root of x squared plus 1 plus x. And this right here, x plus square root of x squared plus 1. Aren't they the same? Yes, they are. The order of addition doesn't matter, meaning we can just cancel. So in the end, ladies and gentlemen, the answer is just 1 over square root of x squared plus 1. So even though this right here might be slightly harder in my opinion, well, I don't know. You guys let me know which one is harder. But this one is definitely cleaner for the final answer. This one, not so much. Alright, so 5 derivative. I usually call this kind of questions derivative battles, integral battles, because we are comparing two similar looking questions at a time. Alright, so these 5 questions, just like a pretty good warm up. And now we'll move to integrals. Alright, here we go. For the first integral, we have the following. So this is question number 6. Looking at integral of cosine x over 1 plus sine square x. And for the second one, we are going to have the integral of still cosine x over 1 plus, but this time it's just sine to the first power x. Alright. You can think about which one is easier and then do the easy one first. Have a look though. These integrals, right, both of them, they involve cosine and sine. And I will tell you, when we are doing calculus, especially integrals or derivatives, sine and cosine, they are best friends. Okay. And the reason is because the derivative of sine is cosine. Right? Okay. Cool. Have a look. This is the technique that you guys learned in Calc 1. Like 2 things that you guys did. The first thing is you use the reverse power rule, which is not so bad. But the harder one is the u-substitution. And then the hard part of u-substitution is that what should we choose for the u? Well, derivative of sine gives us cosine. We do have the cosine on the top. Right? So that's a good hint. I would like to tell you for this right here, we are going to let u equal sine x. Because again, if we look at this and differentiate that, du is just going to be cosine x dx. And that's exactly what we have right here. And this is how I like to interpret this kind of things. When you're looking at the integral like this, always pay attention to d whatever. Here we have dx, so I call this the x world. I don't know how to integrate that, so we did a u-substitution. So what we have to do now is to take this integral from the x world to the u world, and hopefully you can see something much better over there. It will. Have a look. This right here is the integral. Let me just put a 1 on the top like this, and this is just the du, so I'm going to put it down on the side. 1 is 1, plus is still plus, of course, but sine square x, remember this notation means sine x inside and then square on the outside, and we say sine x is equal to u, so we just have u and then square that. So that's the integration that we have to do. But to integrate 1 over 1 plus u squared in the u world, we have to ask ourselves, and this right here is doable, right? We have to ask ourselves, the derivative of what will give us 1 over 1 plus u squared? And the answer for that is inverse tangent. That's why I did that with you guys earlier. So here, once we're in the u world, we can see that we just get inverse tangent of u. And let's save one step by, because we know u already, so we're just going to put that down. We don't need to write the u and then write the inverse tangent of sine x again. Let's just put that down right here now. Sine x right here, and then we are done. This is the first time we're doing this in Cal 2, huh? Don't forget your plus c. Yeah, the constant of integration. So that's what we have. Now, for the second one, can we also let u equal sine? Yes. We have a sine right here. But let me tell you though, I'm going to let u equal 1 plus sine x. And notice, earlier, I did just let u equal sine to the first power, not sine to the second power. Because if you let u equal sine to the second power, you have to bring the 2 to the front, and then you have the sine x, and then do the chain rule, so you have cosine x. That's not what we have on the top, right? But anyway, always just write down the u and differentiate. Always just write down the u and differentiate. And the reason that I brought the 1 with us is because when we differentiate the 1, no more, right? So just bring the 1 with us. Yeah. So du is equal to cosine x dx. Nice and clean, because on the top here, we have that cosine x as well. All right, this right here is the integral. That's the du, so let's put it on the side, put a 1 on the top over. The bottom here is our u, like so. Okay, integrating 1 over u in the u world, ask yourself the derivative of what will give you 1 over u, and the answer is ln, right? So we have ln u, and u is that, so we can put down 1 plus sine x. Now, when we integrate 1 over whatever, usually we put the absolute value right here. I can make another video explaining why we have the absolute value. But in this case, remember the biggest value and also the smallest value for sine is from -1 to +1. So if this is -1, but we add 1 already, well, that's going to be, the worst case is like 0, but it's never going to be negative. So we don't need the absolute value, we just need the parentheses, and then put the plus c. Yeah, we don't need the absolute value because the inside is always, well, it's never negative, so yeah, just like that. And yeah, what else do I want to say? And I will talk about that maybe in another video, but that's how you do it. That's how you do it. Yeah, that's about all. See. Okay, yeah. Integration is really hard, especially when we first started. So it takes a lot of practice. Huh? It takes a lot of practice. Number 7. Integral. Well, here, did I put the tangent or secant first? I put tangent first. So I put tangent 2x and then secant 2x dx. All right, so that's the first integral. For the second part, I moved the 2 to a different place. Check this out. We are looking at the integral tangent. I put the 2 here. So now it becomes the power, of course, right? And x and secant square x dx. All right, this one is slightly easier. Do a u-sub. And let me just do everything properly for you guys, right? To make things super clear. I'm going to let u equal 2x. Just the inside function, 2x, 2x. They match, so it's beautiful. Let's go ahead and differentiate both sides. So du is equal to 2, right? It's just the number 2, but differentiating x, we technically put on a dx. And now, I don't see the 2 here, so I would like to do this for you guys. I am going to divide the 2 on both sides so we can isolate the dx. Dx will be du over 2. So let's go ahead and do that. So now we can take this integral from the x world to the u world, and we will see this is the integral tangent. This is our u now, so I'll put that down here. And then we have secant u. And the dx is the same as du over 2. Very nice. Check this out. This is 1 over 2. It's just a constant multiple, so we can take that and put it on the outside of the integration. So we have this 1/2 here. And how do we integrate tangent x, secant x though? Well, think back to the derivatives. Is there any derivative what function will give you secant tangent? Yes, there is. And the answer is secant. So that's one of the things that you definitely have to remember. Remember that when we differentiate secant x, this will give us secant x times tangent x. And of course, here we are talking about u, right? So when we go from here to here, we'll just say, hey, that's going to be secant u. But again, u is 2x, so let's just put that down already, and we are done. Put plus c. So you definitely have to know the derivative table really, really well, especially the trig functions and also the inverse trig functions and also the logarithm and also the exponential. Which is this right here, pretty much. Oh, I don't know how to do this one. Okay, I'm just showing off my back of the t-shirt, but it's hot. But anyway, let's take a look at the second one. This now, they mean the power, right? So tangent square, secant square. Let me tell you a story. In integrals, tangent and secant, they are best friends as well, just like sine cosine. Why? Because the derivative of secant is secant tangent. And now what's the derivative of tangent? I might as well put that down right here for you guys real quick. If we differentiate tangent x, we get secant square x. So you don't have to do any proof for this. You can just write down the answer. But if you do want to know how we come up with that, you can review my other video for it. Hey, if we differentiate tangent x, we get secant square. we happen to have secant squared right here, right? So let's go ahead and do the following. We are going to let u equal not tangent to the second power. We don't like that. If you have a 2 right here, you have to do the chain rule and all that stuff. I just want u to be tangent x, not tangent to the second, all right? And now you see when we differentiate this, we get nicely just secant square x dx. Very nice. This is our du. So we are looking at integral. This is u, and then we have to square that, and this whole thing is du. Perfect. Now integrating this, we can just use the reverse power rule, add 1 to the power, which is 3, divided by that, so we get 1/3, and then u, which is tangent x, and then to the third power. And then we are done, so put a plus c. But usually when we have the power, I would like to write it down right here. Tangent 3 right here and x plus c. Alright. So that's number 7. And now let me just double check if this is still recording. It is. Very nice. 36 minutes already, and I'm recording this in 4K for you guys, but it's going to take me a long time to upload this. So you guys can watch this video in 4K, but the thing is that I know you guys are all using your phone, so it's not ideal to watch the video in 4K. So you guys can take a guess at how I record my videos. Do I use a camera or like a camcorder, or is there any other device? But I'll leave that to you guys. Okay, number 8. Integral 1 over square root of e to the x dx versus integral 1 over square root of e to the x minus 1. Again, they look so similar, huh? This right here just has the minus 1. Remember, we can do algebra first before the derivative and also integrals, right? So let's go ahead and do that right here. Square root, it's the same as 1/2 power. So this right here, integral 1 over 1/2 power here, e to the x. So e to the x and then to the 1/2 power, we can multiply the powers together. So this is the integral 1 over e to the 1 over 2x power. But we can bring this to the top and then make it into a negative exponent. So this right here is the integral e to the negative 1 over 2x power. Alright, now I would like to show you guys a much better way to do integrations. Especially if you notice here, when you differentiate, the derivative is going to be negative 1/2, which is just a constant. Whenever that's the case, you can go ahead and do the following. So this is like integration in your head. So I want to show you guys this first, and I'll show you guys the long way to do this. Alright, here we go. Whenever you do this, it's like you put u to be this. Well, integrating e to the u is just the same thing, so we're going to write that down. E to the same thing, negative 1 over 2 x. Now we have to ask ourselves, what's the derivative of this? Negative 1 over 2, right? But remember, we are doing the integral. We can also think about the antiderivative. So we have to divide it by the derivative of this, which is going to be divided by, sorry, which is the same as multiplied by negative 2 over 1. So just like that. And we're done. Put plus c. But of course, I can write it as negative 2. And this is the same as the original, so perhaps I can write it down like negative 2 over square root of e to the x power plus c. Alright, I'm going to explain now. So what I did was, I let u equal negative 1 over 2x. And then this way, we can differentiate both sides. We get negative 1 over 2x dx. Well, I want to isolate the dx. We can multiply by negative 2 on both sides. So you see, dx will be negative 2, right? du. So if you look at this integral here, this is integrating e to the u, and the dx is negative 2 du, and this is just all multiplication. And now you can see that we can put the negative 2 on the outside. And then we have to integrate e to the u du. And again, that's just negative 2. And integrating e to the u is just e to the u. And u is that. So that's exactly what we get. So let me put that down right here. And then plus c, of course. But this right here is taking too long. Whenever, if you differentiate the inside function, if it's just a constant, you are not going to multiply by the derivative right here. You are going to divide it by the derivative right here. That's why we did negative 2 over 1. Multiplying by negative 1 over 2. It's the same as, right? Dividing by negative 1 over 2, it's the same as multiplying by its reciprocal. So that's what we did over there. And that's the reason. Check out my other video. I have another video on how you can do this kind of questions in your head. In fact, for question 7a, you could have done the same thing earlier as well. I just forgot to mention. Anyway, this right here is a slightly harder one. Check this out. Well, we need to use u-substitution, huh? But if I let u equal e to the x minus 1, you will see du is going to be e to the x dx. But unfortunately, on the top, I just have 1. I don't have e to the x. So I would like to do this one for you guys right here. For this integral, perhaps is the hardest one on this assignment. What we'll do is we will actually let u be the whole thing, square root of e to the x minus 1. And now let's go ahead and get the du. So do the derivative. So you see, whenever we are doing integrals, we have to know the derivatives. Differentiating square root, we get 2 square root of that on the bottom, just like what we did earlier. And then use the chain rule. Derivative of e to the x minus 1 is just e to the x here. And then we have the dx. Now I want to isolate the dx for you guys. We can do so by multiplying the reciprocal on both sides. So dx equals, this will be on the top, 2 square root of e to the x minus 1. That will be on the bottom. And then we have the du on the side. Does this really do us any good? Well, have a look. If you do it this way, it will be much quicker than letting u equal to just the inside. Alright, let's see. This is going to give us integral. On the top we have 1. On the bottom this is u because we said so. Dx is equal to all this, which is 2. But notice, here we have square root of e to the x minus 1, which we set it to be u already, huh? So this is the same as u. I'm going to put down u right here. Why? Because this way that and that can cancel. Very nice, right? However, we do still have the over e to the x right here, and then du. Check this out though. We are having the integral of 2 over. Perhaps I'll put the 2 on the outside first. 2 integral 1 over, right? 2 is on the outside. Here we have e to the x on the bottom. Alright? And then we have du here. Can we proceed and say, this is e to the negative x, and maybe do things similar to that? No, we cannot do that, because you have to remember, in the u world, x is not allowed. No, you cannot integrate this as how it is. But you know what we can do? Look back to what the u is and just make a change. You just like give the makeover. Have a look. U is equal to square root of e to the x minus 1. We can first square both sides. Square this, square that, so they cancel. So we're looking at e to the x minus 1 is equal to u squared. And then add a 1 on both sides. E to the x is equal to 1 plus u squared then, isn't it? So now you see we can put this right here. So we're looking at 2 integral 1 over 1 plus u squared, and now we can be happy because everything's in the u world. So let's see, 2 is just 2. Integrating this, we once again get an inverse tangent. It happens a lot, I would say, in the inverse tangent. And yeah. Alright, inverse tangent of u, and u is equal to that. So I'm going to just put that down right here. So we have the square root of e to the x minus 1. And we are done. This right here is it. So that's the answer for that. So this right here, I would suggest you guys, once you see the solution right now, just kind of put the solution or put your notes, put your homework aside, and write this down again. Try to see if you can redo it on your own. Right? Try to see if you can do this question 100% on your own. If you could, that means you really understand how this works. You just have to remember, you cannot have x in the u world. You must do the change. Sometimes this works, sometimes not. So yeah, that's all I can say. I'm not trying to be funny. It's just how integrals are, because sometimes you may not even have the answers for integrals. All right, so that's number 8. Alright, number 9 is also a pretty difficult one. Number 9, we have the integral 1 over 1 minus square root of x, dx that. And then right here, I'm just going to put down versus integral 1 over square root of x plus 1 minus square root of x dx. And let me take a look. We are doing okay. 48 minutes. Alright. Is the answer right here is just ln absolute value 1 minus square root of x? Is that the answer for this one? No. It only works if you have a linear function. That's how you get the ln. This right here, it's not the answer. It's actually part of the answer by coincidence. But no, don't do that. I will tell you that this right here is slightly easier. This is how you do it. Right here, you see that we have 2 square roots on the bottom. It's actually a really good idea for this one to multiply the top and bottom by its conjugate. So let's multiply the top and bottom by this. Let me just erase this a little bit. Put the dx right here. I'm going to multiply this by square root of x plus 1, but change the minus to a plus right here, and then do the same thing. Keep the same second term. And I'm going to multiply the same thing on the top. Okay, now when we multiply this out, this times that, we just get x plus 1, right? And you see, when we multiply by conjugate, it's just the first thing you square that, you get this, and then you minus the second thing squared, which is just going to be x. You can multiply this out, this times this, you get that. This times this, it's the same as this times that, but opposite signs, so they cancel. And the last one is negative square root of x times positive square root of x, you get this. And you see, this and that cancel out. So on the bottom, it's actually just 1. So we are actually looking at the integral. Here we have square root of x plus 1. And the inside is just a linear function. So I'm going to look at that as parentheses to the 1/2 power, and then x plus 1 and we add this right here, same thing, x and then 1 over 2 power. Over 1 doesn't matter. So that's what we have. And now I wanted to tell you, right here, if you do a u sub, u equal x plus 1, du and dx is the same thing. So this is how you can do it. Just go ahead and add 1, which you get 3 over 2. And we'll have to divide it by the new power, which is the same as multiply by its reciprocal, which is 2 over 3. Likewise here, we add 1, which will get 3 over 2, and then multiply by its reciprocal, which is 2 over 3. This is it. So we have 2 over 3 x plus 1 raised to the 3 over 2 power plus 2 over 3 x to the 3 over 2 power. That's it. And again, the derivative of the inside is just 1, so that's why you don't have to do anything crazy. Alright? Now, for this one, don't try to multiply the conjugate. It doesn't work out nicely, because if you tried it, you will get 1 minus x on the bottom and 1 plus square root of x on the top. That's crazy. We are just going to do a u sub right here. Let u equal 1 minus square root of x. And you have two choices actually. You can differentiate this right now, or you can solve for x and then differentiate. Let me show you guys if we solve for x first and then differentiate. That's the first time we're doing that right here, right? I would like to bring this to the other side and bring the u to the other side. So we're looking at square root of x equals 1 minus u. And then to get x by itself, of course, we square both sides. X is equal to 1 minus u square. Now I differentiate. Dx is equal to, bring the 2 to the front, minus 1. So we have 2, 1 minus u like so. And then don't forget the chain rule, multiply by the derivative of the inside, which is going to give us negative 1. And here we have du. Right, so that's what we have. Alright, so keep that in mind, and now let's take this integral to the u world. We will have the integral 1 over, we make the whole thing to be u, so let's go ahead and do that, put that down. Dx is nicely equal to this already. We have a negative 2 right here, so let's go ahead and write it like this, negative 2 times 1 minus u, and then du. So that's what we have. And let me just put it down like that. Cool. Alright, now clean things up a little bit. We can put the negative 2 all the way on the outside, and then looking at this on the top, 1 minus u over u, and then in the u world. Well, what can we do? Split the fraction, yes. So we're looking at this as negative 2, still have to integrate 1 over u, right? And then minus u over u, but that's just equal to 1. So I'm just going to write it down as 1 now, and then we are in the u world. And now let's integrate. We have a negative 2 on the top. We have a negative 2 in the front. Put down a parentheses for the result of the integration. Integrating 1 over u in the u world, we get ln, and the u is that, so I'm going to write that down, 1 minus square root of x. And in this case, the inside could be negative, so we do need the absolute value. So put that down. And then integrating minus 1 in the u world, we should get u, right? But u is equal to that, so I'm going to just put that down right here, 1 minus square root of x. So this is the u part, like that. And I would say this is a totally okay answer. If you would like, you can multiply the negative 2 inside. So perhaps we'll do that. And no, actually, let's just write it down like this, because if you write this down on the test, that would be totally cool with your answer. So just leave it like that. Yeah. So number 8 and number 9, they were the hard ones. And then the other ones, not so bad. You'll see. How are you guys doing? What did you guys do in the summer? PS5 or I don't know, traveling to Vegas or San Diego, San Francisco, Hawaii, I don't know. Okay, let's take a look at number 10. Okay. First one, we will be integrating sine x times secant square x versus the other one. I changed the sine to tangent. Then we have the secant square x dx. Okay. Didn't we say sine and cosine are best friends in integrals? What's sine and secant doing? No good, huh? But it's okay because we know secant is the same as 1 over cosine. So we can rewrite that. So this is the same as integral. This is sine x. And for the secant square, it becomes 1 over cosine square x. Perfect. So this right here, we're just looking at integrating sine x over cosine square. So right here, perhaps we can just do a u-sub right here, right? So let's go ahead and do that. I'll put this down in blue. Sure. I'm just going to let u equal cosine x. du will be negative sine x dx. We do have a negative. This is how I like to do it. I like to just show you guys a cancellation. So I would like to isolate the dx. Because unless you multiply negative, but if you don't like to do that, some students don't, just isolate the dx so you can see the cancellation, so you can see we still need the negative. So dx is equal to du over negative sine x. So now, let's take this integral to the u world. We are looking at integral. This right here stays. I haven't cancelled out anything yet. Cosine x is the u, and it's just u, and then we have the second power. And the dx is that, which is du over negative sine x. From here, we can see this and that cancel, and we do need that additional negative sign. And we can write it down like this. Put the negative all the way in the front, integral, and to integrate 1 over u squared, this is not the natural log situation. We will have to write this down as u to the negative 2 power. And then right here, I'm going to just use the reverse power rule. I'm going to add 1, which will get negative 1, and then divide it by this new power. So I'll just put down 1 over negative 1. So in the end, you'll see that negative times negative becomes positive, and we have u to the negative 1 power. So I'm going to write it as u to the negative 1 to make it clear for you guys. But u is equal to... Oh, I see a very easy way to do this. Oh my god, I feel so embarrassed now. I came up with this question and I realized, let me finish this and I'll show you guys the easy way. U to the negative 1, u is equal to cosine x. So this right here is equal to cosine x and then raised to the negative 1 like this. And this means 1 over cosine x. When we put the negative 1 on the outside, it means 1 over. So what's this? Yes, this is just equal to secant x, right? And then we're all done, so we can put the plus c. And we are done, all right? You can do this, especially when you have like secant to the 3rd power, 4th power, 5th power. Go ahead and do this. No problem with that, okay? But I just recognize a much easier way to do this particular equation. So I would like to do that for you guys real quick. Check this out. Nothing wrong with this. It's just in this particular situation, it's a much faster way to get secant x. Ready? Secant square x is equal to this. Check this out. This is the same as integral. Let's look at sine x here. And because we have 2 of the cosine, right? 2 of the cosine x on the bottom, so I'm going to put down 1 cosine x here. Actually, let's do this. Let me actually put it as, no, let me do this. Let me just break this apart. This is what happens when you are trying to teach or when you talk and then it's so hot. You guys can see the sweat and my head's burning. But anyway, let's go ahead and continue. I'm going to break this apart as secant x. And then right here we have sine x, right? And then another secant x. But secant x is the same as over cosine x. Right? Because this is also secant x on the bottom. And the purpose is that sine x over cosine x is tangent. So this is just asking us to integrate secant x, tangent x, which if we remember our derivative table, then we will know that this right here is just nicely equal to secant x. And we are done, plus c. That's it. That's it. But earlier, you would do that if the power right here is bigger than 2. Let's say 5 or 17. Then you definitely do what we did earlier. Okay, for this one, you actually have 2 ways to do it. So let's go ahead and talk about it. First way, I would say that's the obvious way. We do a u sub, let u be tangent x. Because this way, we see du is just equal to secant square x dx, which is this part right here. So we can say this is the integral u times du. And when we integrate u in the u world, we get 1/2 u, which is tangent x, and then square. And that's pretty much it. Put a plus c. And of course, you can also put a 2 over there for the power. All right. Another way to look at this though, it's the following. If you take a look at the integral and tangent, I'm going to write it down like this. I'm going to break this apart as secant here. So I'll just say this is or secant square. I'm going to first put secant x right here. And you will see we'll actually do this quite often in especially the calculus 2 integrals. Break this apart, secant x first, and then another secant x, which is definitely secant square, and then let me write down the rest, which is tangent x and then dx. If we look at this way, you can see that we can let u equal secant x as well, and du will be secant x times tangent x dx. So this right here is the same as integrating u, and then the whole thing here is just du. And of course we get 1/2, but this time our choice for u is secant. So secant x square plus c, which is 1/2 secant square x plus c. If you do this on your test or whatever, this right here is totally okay as well. And of course this right here, nothing wrong with it either. But does that mean this and that are the same thing? No. This and that, of course, 1/2 tangent square x, it's not the same as 1/2 secant square x. They are not the same exact function. The reason that you see these two, the reason that you see we end up with two very different looking integrals is because in the end here, we have the constant. This right here technically should be C1 because I'm doing this 2 ways. So I will put down this constant C1. It will be different than that, C2. The idea is that this and that, we'll just put this down for you guys. We call this 2 functions of by a constant. Yeah, I have another video for this already in more detail. So if you have seen this before, then you know what I'm talking about. If you want to know more about this, you can ask me in class or check out my other video for that. All right, 10 questions. Let me see. Wow, 1 hour. I was thinking I can finish all 40 questions in 1 hour, but of course not. Okay, so yeah, they're off by a constant. This is a pretty cool phrase you should remember. Okay, 10 questions, we finish, huh? The first 5, just derivative. And then the second 5, just integrals. Here is the fun part. For the rest, we'll be doing one derivative and one integral. And the function is actually the same. Who set this up? I did. You can let me know which one is the hardest question for you. And then you can let me know in class or let me know in the comments. And if you are not in my class, if you are just somebody from the internet, then hello. And hopefully you are taking your Cal 2. Hopefully you are, how should I say? Hold on, let me just finish erasing. I want to say, I wish you the best in your Cal 2 class. There we go. San Diego. Okay, so here we go. Number 11. First one, we will be differentiating the cube root of x squared. And then we'll be integrating, yes, the cube root of x squared. All right? I think I can almost promise you we finished the hard questions already, number 8 and number 9, and the rest is just review purpose. Okay, anyway, let's get started. For the first one, whenever you see radicals when you are differentiating, just go ahead and change that to a power form. So this right here is the same as differentiating. You have to remember this right here is the same as x to the 2 over 3 power. All right? So this right here, the third root or the cube root, as we say, is the over 3 power right here. All right? So make a change first. And once you have that, you can use the power rule. You can just go ahead and bring this power to the front, minus 1. So you will end up with 2/3, and you have x to the 2/3 minus 1 is just going to be negative 1/3. And if you would like, you can bring this down to the denominator. So we have 2 over 3. This becomes another cube root on the bottom though. So just pay attention to a negative 1 over 3 power. So it's like that, and then we're done. All right, for this one, same thing. We will be looking at this as integrating x to the 2 over 3 power dx. You see, the challenge right here is that you have to distinguish when you are differentiating versus when you are integrating. When you are integrating a power function, you add 1 to the power, which you work that out, you get 5 over 2. Sorry, 5 over 3. And then divided by the new power, which is the same as multiplied by its reciprocal. So this is how I usually like to show work. Final answer, 3 over 5, x to the 5 over 3. And you don't really have to write this down into the radical form. You don't really have to do that. If you circle this or box that, it's totally okay. This is okay too. And remember, when we are integrating, put down the plus c. Don't do plus c over there. This is it. Okay, good. Right, number 12. We will be differentiating, first one, tangent x, and then number 2, part 2, integrating tangent x. Well, I know the first one is just going to be secant squared, so perhaps if you would like, you can just write that down real quick, and then that's it. We did that many times. And for this one, well, the answer is just ln absolute value secant x plus c. This is perhaps one of the hardest parts, is that students tend to, once they did a lot of integrals, then they just forgot about the derivatives and then they mixed up. So that's the exercise. I would like to show you guys how we get from there to there because it would be helpful to see how this is done as well. Okay, to differentiate tangent, you can look at tangent x as sine over cosine. But here we don't do the u-substitution. Here we do the quotient rule. So let's go ahead, square the bottom. So we have cosine x square, and then we put the cosine x on the top, times the derivative of the top, which is cosine x. Derivative sine x is cosine x, and then minus the top function, which is sine x, times the derivative of the bottom, which is negative sine x. Alright? Okay, this times that is cosine square x. And this times that is positive. And we have sine square x. Over the bottom is cosine square x. Well, we have what? Cosine square x plus sine square x. This is the famous Pythagorean identity. And we get 1. So we are looking at 1 over cosine square x, and that's exactly secant square x, and that's how we get that. Okay, for tangent, you can do it this way. You can go ahead and just say integral sine x over cosine x. But for this one, you don't do the quotient rule, you do the u-substitution. Let u equal bottom cosine x. Because this way, you see du will be negative sine x dx. On the top, I have positive sine. So if you isolate the dx, then you can see the cancellation. I think I would prefer to do that for you guys. So let's do that. Dx equals du over negative sine x after we divide this on both sides. So we are looking at the integral sine x over, this is our u, dx is that, which is du over negative sine x. And we can see the nice cancellation of the sine x and the sine x. We have this negative, we can put it on the outside. And then we are looking at the integral of 1 over u in the u world. And as you can see, this is just going to be negative ln absolute value of u, and u is cosine. And we do have to keep the absolute value because the cosine x can be negative sometimes. So you have to have that. And then you are pretty much done, plus c. But the reason that I put this down as the standard result is that we see we have the negative right here, right? We can put that to the power. So we can look at that as ln absolute value of cosine x raised to the negative 1 power. This right here is the same as 1 over cosine x. And of course, that will give us the secant x. So this right here is the standard result. And as I said earlier, you can actually just go from here to here when you are doing your problems later on. Likewise, you can just go from here to here when you are doing your problems later on. But this is just how you do it. And let me check if this is recording. Okay, recording pretty well. That's it. Oh, let me know where are you guys from. If you haven't met, if we haven't met, then I will tell you I'm a teacher at a community college. But if you're my student, then of course you know who I am. But I'm just saying hi to the people on the internet. I just want to find something to do while I erase the board because I'm not going to cut this video, as I said. Alright, that was number 12, and now let's look at number 13. differentiating 2x plus 3 and then raised to the 5th power. And yes, for the integral, we'll be integrating 2x plus 3 to the 5th power. And I can almost promise you differentiation is always easier than integration. So let's do this one first. To do this, we can just do it right now because it's pretty much ready. Power rule first. So we get 5 and then 2x plus 3 stays inside and then to the 4th power. And don't forget the chain rule, multiply by the derivative inside, which is going to be a 2 right here. So altogether we have 10, 2x plus 3 raised to the 4th power, and that's it. We don't need to put on the plus c. For this one, I wanted to just do this for you guys, right? So perhaps I'll put it down right here. Check this out. The derivative of the inside is 2, which is just a constant. So we can do the following. Integrate this to the 5th power. We can do so by adding the 1. Right, let me just write that down. Add the 1, which is 6, and divide it by the 6, which is 1 over 6 right here. But that's the whole form. But as I said, we have to divide it by the derivative inside, which is 2. So divided by 2, we put the 2 on the bottom, so it's going to be 1 over 12. And then 2x plus 3 to the 6th power, and then we are done, plus c. So that will be it. So this is the beauty whenever the inside function is just going to give you a constant for the derivative. But again, just for practice purpose, I will show you guys how we actually end up with that. Just to make things more clear for you guys. Just don't like this integration sum. Okay, so do a u-sub. Let u equal 2x plus 3. And you see du will just be 2 dx. And you see divide both sides by 2, dx is equal to du over 2. So we are looking at integral here, and then we have the inside being the u to the 5th power, but we have the du over 2. And right here, we can integrate. Of course, we can put the 1/2 in the front. But let me just integrate now, which I have to add a 1, which will give us a 6, divided by the new power, so I put on 1 over 6. So this together will give us 1 over 12. U is that to the 6th power, and then we are done. So put a plus c, just like that. Okay. So this is the thing you can just go from here to here. Yeah, it's much more preferred. Because if you do this every single time, calculus 2, it's going to be really, really long. Yeah. All right, we continue. You guys will either really like this one or maybe, I don't want to use hate, but like, I don't know. Number 14, we will be differentiating. Do you guys know the most famous constant in math? Yes, pi, but in calculus, it seems that e is more famous. Because when was the last time you differentiate pi to the x power? Maybe you haven't, so we'll do that. Differentiating e to the x is everybody's favorite. It's just always e to the x. But we'll differentiate pi to the x. And of course, let's also integrate pi to the x. Alright? As I said, e perhaps is more famous than pi in calculus because of the following. If you want to differentiate pi to the x, what we have to do first is rewrite the pi as, we'd really like to have e for the base. So we look at the pi as e to the ln pi's power. Is this okay? Yes. E and ln cancel, so we still have the pi back. And of course, we still have to raise this to the x power, like so. But this power and that power, we can just multiply them. So we're really looking at this as differentiating e to the pi. Sorry, let's put down the ln pi. Well, let's put down ln pi first. Multiply this and that together, so ln pi, and then multiply by x. So make sure that you don't put the x next to a pi. Use a parentheses to make it more clear. It's just a number multiply. This is a number multiplied with x, like that. Now we can differentiate. Differentiating e to the whatever, we just get e to the same thing. So let's write down e to the ln pi. Again, let's use a parentheses and then the x right here. And then we use the chain rule. Multiply by the derivative of this. Since this is x to the first power, so this will be the derivative. Then we just get ln pi. This right here will give us, what's this? It's just the original. So we have pi to the x times ln pi. Done. I will tell you guys the formula at the end of this, the quick way. But anyway, to do the integral, we do the same thing. So still look at pi. We cannot run away from e. We know this is the same as that, so I'm just going to skip to that step. So this is going to give us e to the ln x. Let me just put it down in red to make it. So ln pi. And then multiply by x. And then we have the dx here. Now, the derivative of this is just a constant, namely ln pi. So we can do what we have done before. Just go ahead and do the following. Integrating e to the u, right? Just look at that as u. You do the same thing. So you just have e to the ln pi times x. But we will have to divide by the derivative right here. So I will put this down right here. We divide, so we will put that. Same thing, so e to the ln pi times x. And divided by the derivative right here, which is going to be ln pi on the bottom because we're dividing. You can put down a plus c, but we are not done yet because I would like to write it as 1 over ln pi. And then this guy is just pi to the x power. And then I will put down the plus c when I box the answer, like that. Okay, so yeah, somewhere here, somewhere there. I'll just put this down right here for you guys. Note, if today we're differentiating anything by base e, let's say we have a legitimate base, let's say b in general, raised to the x power. This right here, you can always do this. And you will end up with the same thing, which is still b to the x, but you will have to multiply by ln b. And this is meant to be inside. So we could have used that. And when we integrate b to the x power, just divide. So we have the 1 over ln b times b to the x power, and then plus c. So yeah, just like that. I'm not going to box this too many boxes. Right, 2 things. Cool. Okay, 14 questions. You might be wondering how come I'm not covering any limits in this video. Because the first 3 weeks or so we'll just be doing integrations. So let's spend the energy on differentiations and also integrations first. Yeah, we will first use limits when we are talking about what we call the improper integral, which is later on. Okay, number 15. Number 15, we will be first differentiating 1 over square root of e to the x. Yes, we have seen this earlier. And then Oh, I really did this. No, let me change the question because we actually integrate the 1 over e to the we actually integrate the 1. Let's do it again. Let's just do it again. Why not? Because you seen earlier, it's like, I don't know, an hour ago. Let's do it again. 1 over square root of e to the x. Right? Because remember, the goal is to compare derivative and also integral. How do we do this though? Well, this time we are going to try to see if we can skip some steps. This is the same as 1/2 power, so we can put that right here. So 1/2 x for the power. Bring that up to make it negative power. So this is the same as differentiating e to the negative 1 over 2x, right? So the more you do this kind of things, you can skip steps. Now differentiating this, we get this back, right? E to the negative 1 over 2x. And don't forget, we multiply by the derivative, which is multiplied by negative 1/2. Pretty much. Yeah, that's pretty much it. Now I would like to write negative 1 over 2 right here. But this guy, it's the same as that on the bottom. So write it as this, e to the x. Yeah. So negative 1 over 2 square root of e to the x. Cool. Now for this, again, integral e, same thing, negative 1 over 2x dx. Remember how we did this earlier? We first repeat this, e to, let's put this down here, e to the negative 1 over 2x. But this time we look at the derivative right here, which is negative 1 over 2. But we have to divide it by that, which is the same as multiplying by its reciprocal. So we multiply by negative 2 over 1. We did this earlier. So altogether, this is negative 2. Bring this down, we get square root of e to the x. Hey, don't forget the plus c. Yes. Very similar, huh? But be really careful with such small thing. And yeah. And then we did this like in question 8a. So yeah, maybe like half an hour ago or so. I have ice cream from Trader Joe's. The coffee boba one. Maybe when I finish the video, I will show off. Let's see. Wait, 20% left for the battery. That's not fun. All right, speed up. All right, first one, differentiating ln x over x versus integral ln x over x dx. Okay, first one, quotient rule. Go ahead, square the denominator, and then put the denominator function, the bottom one right here, multiply by the derivative of the top, which is 1 over x, and then minus the top function, which is ln x, times the derivative of the bottom, which is going to be 1, like so. So altogether, we have 1 minus ln x over x squared, and then we are done. For this, we do a quick u-sub. U equal ln x, du equals 1 over x dx. Check this out. It's right here, 1 over x dx. So this is the integral, ln is the u, the rest is the du. Here, be careful, we get 1 over 2 u, and for the u is ln, so I'm going to write down ln x, and then I'm just going to put down a parentheses, and we have to raise that to the second power, and we are done. Put a plus c. Some people might put a 2 right here, that's okay, but I want to make it more clear, so just like that. So that wasn't too bad, huh? Number 16. Yeah, so I'm using a phone to record, and then apparently I only have like less than 20% left, so I will have to speed up a little bit. Okay, number 17. First, we'll be differentiating x times square root of x squared plus 1. And then, after we finish differentiating, of course, let's also try to integrate square root of x plus 1 with the x in the front. This guy, we need the product rule, right? So first, we multiply x with the derivative of the second. Differentiating square root, we get 2 square root of the same thing. But don't forget the chain rule. We are going to multiply by the derivative inside, which is 2x. And then we are going to add the second function times the derivative of the first, which is going to be just x, just 1. All right, now let's see. This is going to give us 2x squared. No, I can cancel the 2. This and that cancel. So we get x squared over square root of x squared plus 1. This is just square root of x squared plus 1. But let's combine them because the result is actually pretty nice. So let's multiply the top and bottom by square root of x squared plus 1. This way, we get x squared and then plus, this times that we just have x squared plus 1 over the same denominator. So all in all, this is 2x squared plus 1 over square root of x squared plus 1. Done. Phew. This guy, u-sub, let u equal x squared plus 1. du equals 2x dx. Isolating the dx, we get du over 2x. Here, this is integral. Let me just write down the x right here. Square root of u, and then dx is that, which is du over 2x. But as we can see, the x and x cancel out, so we don't have any trouble at all. 1/2, we can put that down all the way in the front right here. Now we have to integrate square root of u. Square root is the same as 1/2 power, and then we have the du. To integrate this, we add 1 to the power, which will give us 3 over 2, and then divide it by the new power, which is multiplied by 2 over 3. Nicely enough, this and that cancel, so we have 1/3 u, which is that, x squared plus 1, and then raised to the 3 over 2 power. And we're done. Okay. Okay, number 18. First, we'll be differentiating sine square x times cosine x. And then next, we'll be integrating sine square x cosine x. Let's do this first. Well, actually, why not? Let's do this first. Here, because the derivative sine is cosine, so we can just let u equal sine x, because that way du will be cosine x dx. Right? Very nice. This is exactly the du. So we are looking at integral, and we have u to the second power. Again, just let u equal to the sine to the first power. And this guy is du. So 1/3 u is sine, so we'll put that down. And you know we'll have the third power we can put a 3 right here to save a step, and then we are done. So maybe this is easier for the first time, right? Now, take a look right here. We will have to do the product rule. So, we are going to write down the first function, which is sine square x, times the derivative of the second, which is negative sine x. All right? And then we are going to add the second function, which is cosine x. And now for the first function, when we differentiate, we bring the power to the front, minus 1. So we have 2 sine x. But don't forget, we still have to multiply by the derivative of sine x, which will give us cosine x, right? Because of the chain rule. So this right here is slightly trickier. And now I'm just going to clean things up. This and that is negative sine to the third power x. And then we have to add 2 sine x. And then cosine times cosine is, of course, cosine square x. And you can actually do a little bit more if you prefer, because cosine square x is equal to 1 minus sine square x. Because this way you can write everything in terms of sine x. In fact, you could have done that in the beginning. You could have written this as 1 minus cosine square and then differentiate that if you would like. It's up to you. But anyway, if we do that, we are looking at negative sine to the third power x. And then we have to distribute this in here, right? So this times that is plus 2 sine x. And this times that is negative 2 sine to the third power x. Just like that. And lastly, we have what? This and that can be combined, so we will do that. So altogether, we are looking at negative 3 sine to the third power x plus 2 sine x. I think this is a pretty satisfying result, I would say. And let me see how we are doing here. All right, good. So, number 18. All right. So be really careful with the chain rule. Like I would say, when we are doing derivatives, the most common mistake is forgetting the chain rule. And when we are doing integrals, the most common mistake is perhaps the plus c. People forget to put down the plus c. All right, 2 more questions. All right, number 19. First one, we'll be differentiating 1 over square root of 1 minus x squared. Next, yes, we'll be integrating 1 over square root of 1 minus x squared. Fun fact, if I make the 2 to a third power, then that's not doable. But anyway, let's do this one first, and this is how. Look at the square root as the 1/2 power, and because we only have a 1 on the top, we can write this as differentiating. Let's just look at this as this raised to the negative 1/2 power with 1 minus x squared inside. Much better. Because this way, we can just go ahead, bring the power to the front, and then minus 1. So when we do that, we will end up with negative 1 over 2. And the inside stays the same. And negative 1/2 minus 1 is negative 3/2. And in the end, don't forget, multiply by the derivative inside, which is negative 2x. That's what we have. And finally, you can just cancel things out. Like this and that cancel, and negative cancel. And for this one, if you would like, you can put the x on the top, over, and this right here turns into a square root, right? This half power turns into a square root. And then the negative we bring that down to the denominator, and this right here is 1 minus x to a second power, and don't forget we still have the third power. We can write it down like this. And in calculus, we don't really care to simplify the square root, and if this is a bigger part, it's totally okay. If you would like, you can also leave the answer like that, up to you. But anyway, let's look at this. What's the answer for this? This is actually much easier too, because it's a matter of remembering the derivative of inverse sine x will give you that, and then you will be done. Later on, we'll be doing what we call the trig substitution. In that case, we can kind of go backwards to do the proof, but like we should have done the derivative of inverse sine x in Calc 1 already. The derivative of this is equal to that, so we are done. We don't have to do anything too much. Alright, last question. You excited? Okay. Number 20. Check this out. First, we'll be differentiating e to the x over 1 plus e to the 2x. Secondly, we will be integrating e to the x over the same thing, you guys know it already. That one first. Alright, this right here, we need a quotient rule. So go ahead, square the bottom right away. We have 1 plus e to the 2x. And then the bottom function, which is 1 plus e to the 2x, times the derivative of the top, which is just still e to the x. After this, we will have to minus the top function, which is e to the x, times the derivative of the bottom. Derivative 1 is 0, derivative of this is e to the 2x, and don't forget we still have to use the chain rule multiplied by 2 right here. So that's what we have. And now let's clean things up on the top. This times that, we get e to the x power. This times that, we add the powers, so 2x plus x is 3x. So we add e to the 3x. And then minus 2, this times that against e to the 3x. Over that denominator, 1 plus e to the 2x squared. And of course, this and that can be combined, so we have e to the x minus e to the 3x over 1 plus e to the 2x, and then square. Done. Okay, for this one, I'll kind of want, no, I'm gonna do this before I run out of battery. Let me see. 10%. I'm going to grab the ice cream for you guys to see, and then we'll do that. I have this from Trader Joe's. Unfortunately, this video is not sponsored by Trader Joe's, but really good stuff. Yeah. So I'm gonna eat this after this question. I don't know. Go ahead and try to figure this out. I also have the ube one, the purple one, the limited one, the good one. Okay, did you guys figure this out? Well, we have e to the x on the top, so we should let u equal to e to the x, so that way they cancel out nicely, huh? What's this? Yeah, this is the key. Check this out. We are going to first rewrite this as e to the x over e plus this right here. It's the same as e to the x and then square dx. Because this way, we can simply let u equal e to the x. Du is just e to the x dx, and that's exactly what we have. If I already see exactly what we have, I'm not going to isolate it because we can just replace it. So this right here becomes the integral 1 over 1 plus this guy, which is u, and then we square that guy, and we have du, which is, told you inverse tangent happens a lot, or maybe I just like to pick the inverse tangent question, I don't know. Inverse tangent of u by u is e to the x. And then we are done, right? Okay, so yeah, 40 questions right here, 40 questions right here, derivatives and also integrals. And let me know how do you guys feel. You feel better or feel ready? You feel like you have a lot more work to do? Things like that, let me know. And that's it. Subscribe to this channel. This channel will be just dedicated to calculus videos, right? So if you guys need more help, you guys can check out my other video for it. If you have any questions, you can leave in a comment down below and let me know. And I wish you the best luck in your calculus 2 class. Or maybe if you're watching this for your Cal 1 or maybe your Cal 3 class, then I wish you the best luck as well. And now I'm going to eat my ice cream. Bye.